In this video, I'm going to talk about Raoult's law. Raoult's law states that the vapor pressure of a solution decreases as the mole fraction of the solvent decreases. And some keywords. In this case, we're referring to the vapor pressure of the solution and the mole fraction of the solvent. So be careful about that. And as the mole fraction of that solvent decreases, so will the vapor pressure of the whole solution. And well, out of this, we can obtain the following formula. The pressure of the solution is going to be equal to the mole fraction of the solvent times the vapor pressure of the pure solvent. And that is represented with this little dot next to it. However, most of the times you'll use a variation of this formula, which you can obtain when some kind of solute is added to the solution. So the formula refers to the change in vapor pressure due to the added solute. And that formula is that the change in vapor pressure, delta P, is going to be equal to negative I times the mole fraction of the solute times the vapor pressure of the pure solvent. So this part stays the same. And now this is our change in vapor pressure, P. I is the number of particles, and the other change is the mole fraction. Instead of being the mole fraction of the solvent, is the mole fraction of the solute, and the vapor pressure of the solvent stays the same. Remember, this circle here represents that the solvent is pure. And well, that is the formula. Now to go into the actual problem, we have calculate the vapor pressure lowering, so the vapor pressure change, when 12 milliliters of glycerol are added to 600 milliliters of water. So the first thing you should do is know that this is the solute, this is our solvent, and we also have that the temperature of the water is 50 degrees Celsius. Also, when water is at that temperature, 50 degrees Celsius, the vapor pressure of pure water is 92.5 torr. So this is our P circle solvent. The density of water is 0.988 grams per milliliter, and the density of glycerol is 1.26 grams per milliliter. This is our data. Also, in this case, our I is equal to 1. So we won't have to worry about that. Going back to our formula, we can see what we have and what we need. So the formula was delta P is equal to negative I times the mole fraction of the solute times the vapor pressure of the pure solvent. We have this. This is 1. So the only thing we're missing is the mole fraction of the solute, because the question is, what is this change? So we need to obtain the mole fraction of glycerol. For that, we need the moles of glycerol, moles of C3H8O3, the moles of water, and then we can obtain the mole fraction. So the formula is C3H8O3 the moles of glycerol over the sum of the moles of glycerol and the moles of water. So I'm just going to write M C3H8O3 MH2O. And let's find first the moles of glycerol. We have 12 milliliters of glycerol and we have the density of glycerol and the molecular weight, so we can convert milliliters into moles. This will be times, let me separate this, 1.26 grams of glycerol over 1 milliliter, that is using the density, times, using the molecular weight, 1 mole of glycerol is 92.09 grams. Let's check our units right. Milliliters will cancel out with milliliters, grams cancel out with grams, and we're left with moles. And the answer is 0.164. Now we have to find the moles of water. We had 600 milliliters of water, and like before, we also had the density and the molecular weight, so that will be times 1 milliliter is 0.988 grams times 1 mole is 18.02 grams, and that is 32.89 moles of water. So now we can finally determine the mole fraction of glycerol. X glycerol is going to be 0.164 moles. Those are the moles of glycerol or solute over 0.164 moles plus 32.89 moles. And that is equal to 0.00496. And mole fraction doesn't have a unit. Finally, we plug everything into the formula for vapor pressure. Delta P is going to be equal to the mole fraction, so 0.00496 times the vapor pressure of the pure solvent or the pure water, which is 92.5 torr. That is equal to 0.458 torr. That's the change in vapor pressure. And that is Raoult's law. Thank you for watching this video. I hope you liked it and found it useful. And if you did, please be sure to give it a like and share it with your friends.